everybody. So perfect, feel free to share your screen.
Okay. Sorry, I have the problem that I'll do this.
Okay, perfect.
Okay, so the thing is, now I need to go in presentation mode.
Oh, yes.
So are you seeing my presentation?
I can see the presentation and the separate slides in PowerPoint.
Oh, no. See, so what I need to do is, let me just move things around.
Okay.
I need to first go into presentation mode and then screen and then share my screen. Sorry, I have 3 screens here.
No problem.
For some reason this morning, they're jumping to different screens than they usually do. You know, it always happens like that. Okay. I can't. Sorry, we'll have to cut this away.
No problem.
It keeps jumping to a screen and then I can't see. Now it will work. Why is it not showing my screen? There, finally, there we go. 20th time, success.
Perfect.
You should be seeing my presentation right now.
That's great.
Okay.
Excellent.
So let me just get a pointer going. Okay, so I don't really know in how much detail to go, so I'm going to pace myself. So I was asked to talk about the impact of grape smoke exposure on grapes and wine. So I'm going to give a short overview of the basic science of the problem, then what we know and don't know. And unfortunately, there's way more that we don't know than we know. And some of the current research that's undergoing, some of it in my lab, to try and answer all these gaps in our knowledge. So this is based on California, but I know there's been some impact in Colorado as well. So unfortunately, climate experts and resource managers sort of agree that the intensity and frequency of wildfires are going to continue to increase. And it is a significant risk to the wine growing regions in California. So, and we know that if you get prolonged exposure to smoke, it can adversely affect the quality of the grapes and of the wines that you make from that. Now, we know in 2020, we had 6 of the 7 largest wildfires recorded ever in California. And about 8% of grapes weren't harvested. An unknown amount of wine was impacted. An economist did an estimate, and he estimated that we lost about $3.5 billion in revenue in the US just based on loss of wholesale wine revenue. So obviously, this is a huge problem. It threatens the sustainability of the grape and wine region, especially in areas where there's a lot of potential for wildfires. And so we need to address this and we need to come up with mitigation actions. So first I'd like to talk about, so what is smoke taint? Now first, if you think of a wine taint is something that comes from outside, it overpowers a wine and it makes it one-dimensional. So it reduces the quality of the wine. That is what we see as a wine taint. Now, in the case of smoke taint, on the nose, you can have smoky, burnt, campfire, medicinal, earthy, and this is not exhaustive list. You get bacon and barbecue aromas on the nose. For me, very characteristic to smoke taint is the lingering retronasal asterisk character that you get at the back of your throat. That is very characteristic. The characters on the nose, you can get through other sources as well. So what happens during a wildfire? During a wildfire, you have a lot of vegetation burning. Now, 15 to 25% of wood is lignin. It gives wood its structure. It's like the crunch in your vegetable, right? So if you look at the structure of lignin, it's this polymer matrix. Now, when it burns, you have thermal degradation of this, and it releases a lot of its components. So if you look at that, there's a lot of ring structures. This is a phenol, and we call it a volatile phenol because it's volatile. This is an example. This is guaiacol. So massive amounts of volatile phenols are being released into the air. Now, they do break down within several hours, but they can adhere or absorb onto debris in the air and be distributed that way as well. And how far they can move and how they move will depend on air currents, topography, wind direction, and many, many other things. So if you now have a vineyard close by and you have smoke that's enriched in volatile phenols, what happens? The volatile phenols in the air can very quickly absorb through the berry skin. So it's inside, it's not on the outside. And as part of the defense mechanism of the berry or the plant, it will attach sugars to it. So it can attach 1, 2, or 3 sugars. So now you have volatile phenols absorbing, they get attached to various amounts of different sugars. So it becomes this really complex issue. More complex is the fact that both free, so the free volatile phenols, and the bound forms, those are the forms that attach to sugars, are naturally present in grapes. And we know that the natural amount varies depending on the variety. It varies depending on the season because there's environmental impacts like temperature impacts on biosynthesis of any compounds within a grape. And we don't know if it will also vary per region. So if you think about this, we have these 7 main volatile phenols that we recommend people should measure. Now, in the beginning, people here in California were only measuring guaiacol and full-methyl guaiacol, but they're not enough to predict. Even if you take this whole list of 7 and all the commercial and all these bound compounds that they make. Now, the problem is in the labs, we do not have standards for these things to really absolutely identify something. In a commercial lab, you need an authentic standard for it, or you need to isolate it yourself, characterize it, and then use it, which is what we many times do in research. It's a lot of work. There's only about 6 of these compounds that we have standards for the glycosides. So most labs that will do individual bound, an extensive panel, and an extensive panel of the free will do 7 free and 6 bound. So that's 13 compounds. The Australian tells me those 13 compounds give you about 70% predictive power. So just remember that the analysis helps, but it's not an absolute indication of what's going to happen in the wine. And this is what we can get. You get a little bit of free and almost everything is in the bound form. So that's why we highly recommend you have to look at the bound as well. You can't just analyze the free. And we don't know what this ratio of free to bound is. We haven't been able to identify a consistent ratio of these two. I wanted to mention different testing. So there's quite a few labs that do free volatile phenols because they're not too difficult to do by gas chromatography, mass spectrometry. A lot of labs would give you free and total. So what the total is you take a sample and you do acid hydrolysis. You basically reduce the pH to 1, and at a temperature of 100 degrees Celsius for 1 hour, you're trying to break all those sugar linkages and release the free. So now if you have the free before hydrolysis and you have the free after hydrolysis, you can subtract these two from each other and get an idea of bound. Something to remember, not everything gets released, even under those harsh conditions, because these linkages are very, very stable. We've seen it's mostly the monoglycosides, some of the diglycosides, and we don't even know if it breaks the triglycosides, but it gives you a small idea of how much potential bound there can be. The other option is to do the individual bound. Now, not a lot of commercial laboratories offer this analysis because it's really difficult. You need a UPLC Q12MS to do this. So it's a different skill set of a technician that you need. And even then, they mostly do 6 individual bound compounds. So you still only see a small fraction of what's out there. So you need as many analyses as you can get because each number tells you something additional and more. But like I'm saying, it only gives you an idea of what's there. It's not an absolute number. So I recommend to people, if you find a lab that you trust, you have a good relationship with, stick to that lab. You can't really compare labs that easily with each other. The numbers won't be identical. But if you use the same analysis, you can start getting an idea of your own sample, what that bound and free means. When did that result in a wine that was impacted? And when did it not result in a wine that was impacted? So it's probably the most common question I get is risk. What's my risk? So at this point in time, we tell people the fresher the smoke, the higher your risk. Now, fresh smoke we see as less than 24 hours. Now, this is totally anecdotal. The Australians had an incident where there was a huge fire, the whole column of smoke went over the ocean, came back over McLaren Vale 24 hours later, and they thought everything was going to be impacted, and it wasn't. So this is something we're actively trying to study. We know that air quality index is not a good measure of smoke taint risk. It correlates the best the fresher the smoke is. But when that smoke gets older, what that air quality index is measuring is a lot of carbon and particulate matter. What's causing smoke issues in grapes are volatile phenols. They're small, you can't see them with the naked eye. So we have a large grant that's starting early next year. And the two focus areas, and this is us, UC Davis, with Oregon State University is the main institution, and Washington State University. We're going to specifically look at developing low-cost sensors and a sensor network for real-time assessment. So if you can put a low-cost sensor in your vineyard, and it can tell you yes, no, yes, you have risk, or no, you don't risk. That will help a lot because you don't have to spend hundreds of dollars on analysis that may not be necessary. And it's also not going to overrun the labs as what we've seen in 2020 because everybody had to test because they had no idea what the risk was. Then we want to link environmental data with chemical and sensory data for predictive modeling of risk to grape and wine quality. So basically, analyze the atmospheric composition, see if we can link that to the actual chemical composition in the grapes and of the wines that we make. And so that we can do predictive modeling. Obviously, for good modeling, you need a lot of really good data. So this will take several years. But if we can predict how that smoke will move, how the volatile phenols will age within that smoke, we will be able to recommend or have a better estimate of risk. This is an interesting study that was done in Australia quite a few years back on Merlot vines over 3 seasons. So they exposed Merlot vines intentionally to smoke at key growth stages. You can see from a 10 centimeter shoot length, flowering, pea size, beginning of bunch closure, variation, grapes with intermediate sugar, and berries not quite ripe to harvest. Those are a lot of growth stages. And they found that the berries were the most susceptible to smoke after variation. Perhaps because the skins are softening, perhaps because they expand in size and you have a higher surface area. We don't really know why. We don't understand the mechanism really well. However, now they've had a lot of incidences where they've had vineyards exposed to smoke very early on, when they've only had pea-sized rock hard berries, and those grapes ended up being highly impacted. So now we're basically saying, look, if you have a berry on the vine, there's a chance that you may be impacted and you should be testing and checking. The good news here is they only absorb onto the leaves and onto the berries. They don't overwinter. So, you hear people talking about, oh, there's smoke in the air forever, or smoke in the woody areas, or smoke in the soils. There's no proof of that. There's no smoke impact into the next year. The only time you would have an impact into the next year, if it's a fire really got very close to your vineyard and your vines overheated and there actually were damage there, then there's an impact, but not from smoke itself. But what about mitigation in the vineyard? So we know washing grapes don't work. They're not on the outside, they're inside the berry. But there's been quite a few studies looking at barrier sprays. Are there something you can spray onto the berry to protect it? Now, Australians published a study on Cowland, so the clay surround. And basically on Sauvignon Blanc and Chardonnay didn't do anything. And then for the Merlot, there was some efficacy and some decrease in volatile phenols. And they explained this variability due to coverage in the vineyard. They say if you spray in the vineyard, you only get 30 to 40% coverage. And they think for the Merlot, they may have had better coverage just due to the canopy structure and the bunch morphology possible. So then there was Matt Newton and Wesley Zandberg in British Columbia. They looked at biofilm and 2 fungicides. So the biofilm was a phospholipid layer called Parka that they used to prevent cracking in cranberries. And they applied it like a week before intentional smoke exposure. And they used 2 fungicides, that's basically oils. And interesting, the oils made it worse, and the Parka actually showed some significant decreases in volatile phenol absorption. Now, why did the oils make it worse? They said it's because it increased the surface area of the berry. I don't know, it could also be like a conduit into the berry. We just know that you don't want to spray anything on that berry that's going to be wet and on this berry surface when you have smoke exposure. However, they did do another test with Parka again when they only sprayed it 1 day before smoke exposure, and they didn't have good results. So once again, we still have more work to do there. Then the Australians just published this paper. So it's a little bit complex, but basically what they did is they took bunches, they cut it from the vines, they dipped it. So how much coverage you have wasn't a problem here because they will all be 100% covered. They actually dipped the bunches in different potential berry sprays, put it in something like a fish tank, and then intentionally exposed it to volatile phenols. Now, the main thing is, this is the control. Nothing was significantly less. This is carbon. It looked a little bit less, but now, do you want to put something black in your vineyard, on your grapes? Something to consider. And it wasn't significantly better. And if you look here, this is Parka. It actually was worse. And here's Surround. Didn't seem to do much. Now, here's the thing. I assumed, because they cut the bunches off the vine, that they basically covered them with a berry spray and almost immediately exposed them. And here's my issue. We know that things should be dry before you expose them to smoke. So this may be why the Parka performed so badly. We will have to look and see and do more evaluations about timing of application. This would always just be a preventative thing. It's not something you can do in a reactive way. We really do not recommend spraying anything while there's smoke in the air. So what I did this season, so last year, a lot of people asked me about ash. Now, in our vineyard here at the Robert Manava Institute, we had a lot of ash, and we actually analyzed these ash, and we analyzed it, heating it to 50 degrees Celsius in the SPM vol. You can see that they do release volatile phenols. So people were concerned that the ash was releasing enough volatile phenols to cause more absorption into the berry. But the thing here is, you can wash it off, but then it lies on the canopy floor, and wet ash gives up more volatile phenols than dry ash. So did you improve anything? My biggest thing is more, do you want fresh ash on your grapes when you process wine? Now, carbon absorbs most things. So will it really release, or would it just continue absorbing if it's in the wine? So last year we did rinse off some ash immediately after the smoke cleared. At harvest time, we made wines with and without ash. But the problem is, our vineyards here ended up not being highly impacted, even though we had 2 weeks of smoke, but it was old smoke. It wasn't fresh smoke. So the results were inconclusive. So this year, we actually made a bunch of ash with the same volatile phenol profile as what we analyzed last year. And we added like 1 gram to each bunch and basically captured everything in a nut milk bag and folded it around so that it stays in the atmosphere of the microclimate of the bunch. And we exposed it, the 0 is the control, for 4 hours, 1, 3, and 7 days. And we now need to analyze these grapes and to see, this is a worst case scenario. If that didn't change anything to berry absorption, then I don't think anything will. Then we're also going to do small scale fermentations with ash of different ages, 4 hours, 1, 3, and 7 days, and see, okay, does this do anything? Because if this doesn't do anything, I really don't think we should be worried about ash, and we should have these answers before next season. Then I also have a lot of berry sprays, some of my own concoctions and what people give me and say, you know, this is going to solve our problem. So I had 12 different berry sprays, but I did it slightly different to the Australians. I actually dipped bunches in the berry sprays, but on the vine. I did not cut it from the vine. And then I waited 3 days for everything to dry, exposed it to smoke, waited another 7 days, and then harvested the bunches. We're currently starting to analyze these grapes, so I don't have a result yet, but I can tell you, if anything here shows any kind of efficacy, we will do more randomized larger trials in the vineyard next season to see if this translates to real life situation in a vineyard. So what happens during winemaking? When you crush your fruit, so these volatile phenols are in the skins, they quickly extract. Remember, a lot of them are glycosylated. So basically, think of red wine. You have the cyanins that give you a red color. They're also glycosylated, have sugars attached to them. It makes them very hydrophilic, meaning they like water. So they extract very quickly. The few studies out there that looked into this, 80% of volatile phenols release after 5 days of skin contact at 25 degrees. Okay. Slow hydrolysis happens during the winemaking process because in the beginning, you still have some enzymatic activity. Those enzymes were released from the grapes during crushing. They do get inhibited by alcohol. So as the fermentation process progresses, you will see less enzymatic hydrolysis, but you also get hydrolysis due to the low pH of wine. It's a very slow process. But a couple of studies looked at how much hydrolysis. We saw about 25 to 30% release until after malolactic fermentation. Australians have looked at wines in the bottle, 5-6 years of wine aging. Those bound compounds are still releasing to free. It's a very, very slow process in the bottle. Now, both free and bound contribute to smoke taint perception. I know the bound is not volatile, but what happens is that it seems we have bacterial enzymes in our saliva that can hydrolyze these compounds in our mouths. So then the bound gets freed in your mouth and you observe it retronasally. So we think it contributes to that asterisk character that you observe when you taste smoke impacted wines. Now, something to remember, humans are very different. 20 to 25% of people can't taste smoke taint. We think it's because they don't have these bacterial enzymes. And also, if you look at the odor threshold levels of these compounds on their own, basically at what concentration can you perceive and identify them? It's pretty high. We have smoke impacted wines at 1/10 of those values because these compounds all have synergistic impacts on each other and they're impacted by the matrix. We know ethanol decreases the observance of it. I think because ethanol is inhibiting the enzyme in your saliva. Same with sugar. 3 grams per liter of sugar is enough to decrease your smoke taint perception. Not remove it totally, but it can help. Volatiles, green character uplifts smoke taint, where fruity characters can help mask it. Similarly, if you have a lot of phenolics, a lot of body, it can help hide the smoke taint. So in 2017, I did this study looking at potential ways to mitigate smoke impact in the winery. Because at that stage for white wines, it is handpick if you can, because obviously you don't want damage to the skins because then it starts extracting and limits skin contact. So if you don't have excessive exposure for white wines, there's still a good chance of making a decent white wine. For red wines, they say, okay, make a rosé. No, a rosé is not always an option, okay? It's definitely not an economic and viable option always. You have to remember you will get less of the volatile phenols in the rosé, but the matrix is much simpler, so it can handle less as well before it will start standing out. Otherwise, I'm saying make the best possible wine you can with as much phenolics and fruity aromas as you can. Because if you need to treat, all treatments lack specificity at this point in time, and they will remove things other than volatile phenols. The Australians were recommending things like fruity yeast, some neutral or lightly toasted oak additions that will add complexity, but not adding to the nutty, toasty, smoky aromas that may come from the fires. And they were recommending cold fermentation temperatures. So I looked at 4 different yeasts. I looked at 3 different tannin additions. This is something Lafort wanted me to try. It's an enzyme and stabilization tannin to try and extract the color as quickly as possible, press, and then ferment on the juice. But it didn't work because the enzyme that gets the color to extract, the volatile phenols extract at the same time. And then I looked at different fermentation temperatures, and they all had 7 days of skin contact. And I can say with 7 days of skin contact, these fermentation temperatures did not help. They all had basically the same amount of volatile phenols. I found that some of the yeast and some of the oak profiles did help hide the smokiness on the nose, but eventually that asterisk character came back. So it helps, but it's not a fix. So then I looked at different treatments after the fact. Okay, you have a wine, it's smoke impacted, what do you do? We looked at different FDA-approved enzymes to see if we can break the bound to the free, because the free is much easier to remove than having to try and remove both the free and the bound. But everything I tried lacked efficacy, and they just didn't release a significant amount of the volatile phenols, probably because they were inhibited by the alcohol in the wine. We looked at activated charcoal finding, we look at molecular imprinted polymers. So that's something that's now getting experimental use approval here in California. It's a polymer where they have a template molecule that in this sense would now be a volatile phenol. And they have a cavity within this polymer that can trap the compounds, basically. Very interesting concept. Then reverse osmosis, spinning cone technology, normally used to reduce the amount of alcohol in your wine. They use the technology to get 2 fractions, and the higher molecular weight fraction they put through proprietary resin and put it back together to remove smoke taint. So basically, I had 4 wines of 4 different levels of smoke impact. From the Lake County fires, I had a press wine. So the press wines, you should always want to keep them separate because that mechanical force of pressing the last juice out of the skins do release more volatile phenols that didn't extract. Okay. So we kept the press wine separate in a free run. So this was my high impact, high to medium impact. This was from the Lake County fires, but a further distance away. So this is a medium impact. And from 2017, I had wines from Oakville. They were the low impact. And this is what I want to show you. So this is the free volatile phenols, all the volatile phenols that we measured added together. And on the left is the control. This is the high impact, high to medium, medium, low impact. You can see all the methods work pretty well, right? That everything reduced volatile phenol significantly. Remember, you don't have to remove everything. You just need to remove up to what is normal. Because a wine that's never been exposed, or made from grapes that have never been exposed to smoke, never turns smoky in its lifetime. Now, what technique worked the best? In this instance, molecular imprinted polymers, then reverse osmosis, then the activated charcoal finding, and then the spinning cone. But this order changed sometimes depending on the wine matrix. So it tells us you need to do bench trials. Just because one method works well for one wine doesn't mean it's going to be the best treatment for another wine, because treatment efficacy is so dependent on the wine matrix itself. Now, this is the total volatile phenol. So this is both free and bound together. And then it doesn't look quite as impressive. You can see here that it still decreases, but not as much as what you saw for the free. And this is because these techniques work way better with removing the free than the bound. Okay. We did descriptive analysis on all these wines. Now, there is a problem that there's a lot of carryover. If you just had a smoke impacted wine, it lingers, and everything after that can taste smoke impacted. So we did a 0.5% pectin solution rinse and waited only 90 seconds. But in general, with a water rinse, you need to wait 2 minutes between evaluating smoke impacted wines. The thing I want to point out here is, if you look at the green circle, this is our control wine made from grapes that were never exposed to smoke. If you look at the left, you'll see a lot of threes and fours. That's the wine that was low to medium and low impacted. So no matter what technique you use, it sort of worked when the impact was pretty low. You look at the right, ones and twos, basically the wines that were high and high to medium impacted. None of the techniques worked that well. Because here you can see ash, that is the retronasal character on the mouth. Peaked with smoke is how the panel described all the smoky characters on the nose. So you can see for these wines, it didn't work very well. They were still smoke impacted. Now, obviously, I treated all these wines the same for research purposes so that I could compare them with each other. In real life, you may wanted to try and treat these wines another time and another time. The problem is every time you treat them, you take other stuff out that is actually positive for wine quality. So I think we will get to a point where we can say, okay, if this is the impact that you have, if this is your number, then treatments are options. Otherwise, it isn't, except if you're going to dilute that wine away, because you're not just throwing more money after a wine that you can't sell. So basically, this is a summary. We really do not have very great solutions at this point. There's always new technology. Since I've done this evaluation, there's new guys out there doing things that people tell me it really does improve the wine, which I will check out in the coming year. The future is to develop methods that is more specific to the problem and will specifically focus on volatile phenol removal. We're working and designing an enzyme that can hydrolyze only the glycoside from volatile phenols, put them all in the free form, and then optimize a resin for the removal of that free, trying to impact as little of the other matrix components in the wine. People ask me about flash to tund. Now, flash to tund is a masking. It doesn't actually remove a lot of the bound or free, but it does mask up because of the excessive amount of fruity aromas and color and phenolics that gets extracted. I just don't know how long that masking lasts. So that is something to consider. What's our current recommendations here in California to the industry? We're like, take the berry sample as close to harvest as you can. Currently, we know volatile phenols changes over the ripening period of the grapes, but we don't know how. So I don't know when to recommend to people to take a sample. So the safest is as close as harvest as you can. But because you never know when smoke is going to come or when a wildfire is going to start, we recommend after variation of people every 2 weeks, just grab a sample, throw it in the freezer. If you need it, you need it. If you don't need it, you don't need it. And then you have at least your own baseline set of samples while we don't have baseline for the industry that you can use to interpret your results with. Then if there's smoke exposure, do small lot fermentations. Yes, do analysis on the grapes. What's the advantage of small lot fermentations? Small lot fermentations, first is easier to analyze the wine. And especially when the people were only analyzing free volatile phenols, like I mentioned, a percentage of that bound will release during the fermentation process. The other thing is you can taste a fermentation. You can sensorially evaluate and get an idea of what the wine would look like if you would make it from these grapes. And it makes for much better conversation between grape growers and winemakers than arbitrarily look at data that you don't know what it means and making a decision. Because without baseline, it's really important and difficult to interpret data. I mean, on the high side, we know if it's excessive amounts, you know it's highly impacted. The problem here is to get people to taste reliable, you need to train them. So we really focus on people needed to make decisions how this would happen before harvest. What's the decision tree? What does it look like? Who takes samples for analysis? Who does microfermentations? Who are your sensory panel going to be? Like I said, 20 to 25% of people aren't sensitive. Then you get a large proportion that is very sensitive. You get medium, and then you get the highly sensitive people that see smoke everywhere. So you really need a control one that isn't impacted, and you need a very impacted one so that you can tell people this is what you're looking for. We're actually getting people to only evaluate it for ashtray character, because not all wines have the smoky aromas in the, when they're young on the nose. And so the one thing that's very specific to smoke that is the ashtray. So it just makes it simpler to only evaluate the ashtray character. But like I said, you need a lot of people. The more people for sensory, the better. You can't do only like 6 samples at a time. You have to wait 2 minutes in between each sample set. Then longer period if you have more wines to evaluate. This is not fast tasting. So, you know, it's a big ask to ask somebody else to taste all these wines. So this is the current research and what we really would like to do. Create baseline data. And so we started doing for the 7 main varieties in California. We're going to need at least 3 seasons because we know there's seasonal variability. So I see that as the one bookend. The other bookend is threshold value. Now, say you have Cabernet Sauvignon and you know what the baseline values are. Now you make a wine. Now, elevated is more than baseline, but how much elevated do you need before it actually a negative quality impact in the wine? So we're trying to figure out what's that rejection threshold. But I just told you smoke impact is very much impacted by, and expression is very much impacted by the matrix. So you're probably going to have to do this for a lot of different cabinets in your wines with different bodies and other characteristics to really find a robust threshold value, or find a threshold value per style, per wine style. So this is what we would like to do for our industry here. The Australians spent like 7 seasons because 3 were impacted. They had 4 seasons, they had 12 wine varieties, they do baseline. So when they do analysis for you, they give you your number on the background of the baseline. So this is individual bound compounds. So if your sample would be like median baseline, you're basically safe. If it's a little bit elevated baseline, you have a low risk. And if it is like this, above baseline, you would be high risk. Okay. And then link this with another step saying, okay, if this is the amount of impact you have, what's your treatment options to help you make decisions? So in 2020 and 2021, we did a lot of fermentations of different sizes. So we recommended bucket fermentations using the smoke tank protocol, which is basically you add a pactylated enzyme, try to get as much of the volatile phenols out, and you only do a 5-day skin contact to make it faster, stabilize it, and then you want to basically taste it. But people haven't actually checked how that correlates with standard winemaking. So this is our 30-gallon research fermenters. This is a 300-gallon larger scale fermenters. And then we have micro fermentations. This is coffee presses. I'm actually doing fermentations in coffee presses. So what we want to do is we figured out now, okay, this relates well to larger winemaking. Then we wanted to know how micro relates to this, because for the baseline we're doing now is we're asking the industry to send us frozen grape samples. That's not enough for us to do bucket fermentations. We do need to do micro fermentations. So we had to do enough micro and bucket with both fresh and frozen grapes to get an idea how they correlate with each other, because for logistical reasons, we're going to do baseline using this protocol. So, and on the threshold side, what we did this season is we actually, in 2020, we got a lot of grapes gifted. This year, not so much, because everybody needed the grape and their grapes and the yield was down. But in one entity gave us Cabernet Sauvignon, Malbec, and Syrah. We have the smoke impacted wines from last year. We're going to make non-impacted wines this year and see if we can dilute them with each other to start with threshold. We also did some intentional smoking of grapes. This is Oakville grapes. Our neighbors are Opus 1, so I did not think they will allow me to do smoking trials in the vineyard. I didn't even ask. We picked the grapes. The grapes are alive, they have enzymatic activity, they will still bind them to do make some of the bound. So we did intentional smoking using these drying trays, made wines from that. The grapes that were smoked versus the grapes that weren't smoked. So, and we will do sterile dilutions to try and determine threshold values for them as well. So at this point in time, all I can say is smoke does not equal smoke taint. And I tell people all the time in media all the time, just because you see smoke in a vineyard does not mean that that vineyard would be smoke impacted. What causes smoke taint is not the ash that you're seeing, it's volatile phenols that you can't see with the naked eye. Doing as much analysis as you can is a good idea, because none of them is obsolete. Each one of them gives you just a small piece of the puzzle. I like to say you get 4 pieces of a 10-piece puzzle, and you need to figure out what's going on and make decisions. Currently, there's no recommended mitigation in the vineyard. There's very limited mitigation in the winery. Yes, if you can, less skin contact. You can use fruity yeast, you can try oak additions, do a lot of phenolic extraction. A little bit of residual sugar can help a lot with that nasty ashtray character. Something else to remember, the moment your wine see any kind of oak, you can't do analysis of free volatile phenols. The oak gives free volatile phenols to the wine and an unpredictable amount. I've seen people trying to analyze 1 barrel, neutral and non-neutral, and say, oh, this is the contribution. No, the contribution is very difficult to predict I looked at a bunch of barrels that were identical, same coopers, same toasting levels, everything. And the variability in the volatile phenols that they produce were over 60%. You really just don't know if there has been any oak contact at all. Amelioration treatments, there's a lot of treatments there, especially if the impact is really low to medium. These treatments can help and remove enough of the volatile phenol so that you're not impacted. It's always just difficult to know how this wine will evolve over time and how it will age. That is always the problem. As fruity aromas decrease, as phenolics in grape starts precipitate or in the wine start precipitating with aging, and your body becomes thinner, smoke expression can become more apparent. It is possible. So, you know, this is two of the students that started helping me in 2017, and obviously we can't do anything without funding. So I need to thank our sponsors, and that is my story.
Perfect. Thank you, Anita. It's very, very interesting. It's a nice, nice encompassing presentation on grapes as well as enology as well. So that's excellent. I see we have a question from Jen in the chat. She's wondering, is UC Davis offering any sensory training?
I'm offering sensory training. So yes, I'm trying to do a little bit of train the trainer kind of thing, because obviously I can't get to everybody. And now with the COVID safety regulations, I wasn't even able to train people in person. So we've started doing, I've done about 3, either I go to bigger wineries and go to their sites and train some of their winemakers, or they have come to me through wine organizations and we've done some training. We're going to start doing workshops again next year. Actually, we already started this year with workshops again, in-person workshops. But yes, I can definitely help with training. Either coming to you guys or somebody coming here and I train them and they can go back to Colorado and train the industry there.
Perfect. That's great to know. We'll definitely have Jen get in contact with you. Excellent.
Okay. And I actually made some smoke impacted wines.
Okay.
High and medium and low scale to try and use for anchor people for smoke tank training. The only problem is these wines were perfect, just smoke. And now over time they're evolving. So now they start on the nose, they start getting these grape-like characters, to the point that I actually did scorpions on them to go and test if they had. I know I sterile filtered them, right? There's nothing in there. It's the smoke expression changing as the wine is aging. So it's just a moving target.
Sure.
It's really difficult, but yeah, I can definitely train on the basics, and I can even send some of those wines we made extra home with anybody to Colorado, so that you can use there for in-person training. Excellent.
That's great to know. That's very useful. So if anybody else has any other questions, please feel free to unmute yourself and ask, or pop it in the chat. So I was just curious. So I guess you're saying, so you obviously UC Davis, Oregon State. Do you know if anybody perhaps towards, say, the Midwest or the East Coast, kind of New York regions, as you know, wildfire smoke is now starting to, whether it's just by spreading across or whether we're getting more fires in regions where we're not seeing before. Do you know if any of those regions will start to have perhaps their own research projects in the next couple?
You know, we would love to have more people. I can tell you that, yes, we've been focusing on the West Coast states because obviously the problem has been more apparent and now continues for the last 5 years, I would say. But we want more people to work on this issue. You know, it's very complex. If you take the Australians, they're great researchers. They've been working on this since the early 2000s.
Yeah.
There's so much we still do not know. So yeah, I think the more people that can collaborate and work together to work on the issue, the better. So that can, anybody from the Midwest sites should just reach out to researchers. I mean, it's mostly myself now in California, Elizabeth Tomasino at Oregon State University, and Tom Collins at Washington State University. And we're trying to pull in collaborators within our own institutions as well to work with us on this, because obviously we're all chemists and food scientists. So we're pulling in atmospheric sciences, viticulture, and other people with other skill sets to help us.
Definitely. I think, yeah, especially kind of in the Midwest, and obviously here in Colorado, there's a lot of hybrid varieties being grown, obviously, to kind of deal with our cold temperatures. So I think that's a huge area to see whether, you know, these hybrids perhaps a little bit more tolerant, or, and especially here in Colorado, growing at such a high elevation with our thicker grape skins, whether they're able to be able to.
That is very interesting, really, because that's the one thing we don't know. We don't know. We have anecdotally observed varietal differences in sensitivity to smoke, but we don't know why. So this is something we really want to work on. But yes, if you're only going to focus on the West Coast, you know, states, we don't really grow hybrids here. And I think understanding the genetic impact, why is this happening? And also, why do different varieties have different amounts of volatile phenols? What impact that biosynthesis, right? Perhaps there's a link there to sensitivity, or is it just a skin structure thing? I think the hybrids would contribute a very interesting part of that question. And it's key. We should really do like a multi-state grant, focus on just looking at varietal impact and sensitivity to smoke.
Yeah, absolutely. I think that'd be very, very useful. Yeah.
Currently, there's not a single grant that specifically focuses on that.
Sure. Yes, that'd be definitely something for the future. Yeah. So another question from Jen. She says that I know ETS has been trying to create baseline numbers the last couple of years. Do you think that those baseline numbers found in California would relate to Colorado, or do we need to create our own baseline numbers?
Okay, I don't know. So it would be interesting to see how our baseline numbers here correlate to Australia. We have no idea. And obviously the varieties may not be, you know, some of the varieties will be grown in Colorado, but not all. So that would be the other issue. So yes, ETS is doing baseline. I haven't seen any of their data. Like I said, I'm doing baseline too. I don't know how, I assume they're doing baseline, so it will, and they will use it for their reports, like the Australia, the AWRI commercial app is using. I assume it's not going to be publicly available. I haven't asked, but you know, anybody working on baseline, is great. I'm working with Dr. Sue Ebler here to try and do baseline for California. We started off with just Cabernet Sauvignon, Merlot, Zinfandel, Syrah, Pinot Noir, Chardonnay, and Sauvignon Blanc. Those are the 7 varieties. But you know, we had a very congested harvest, and we only had this little money, so we could only accept so many samples. So we went to 2 big guys. They offered so much grapes. We went, okay, we're done, right? And then with harvest, we didn't get all the samples we wanted. So we started plotting all the samples, and we got plenty for Cabernets and Chardonnay, but for all those varieties, we did not get enough samples, right? So we'll have to improve upon that for next year, and also not covering all the regions yet. Napa Sonoma, yeah, because it's easier for us, they're closer. But you know, we want to go beyond that. We need to go Central Valley, Central Coast, and you know, and the hills, the Amador Hills, which were impacted this year with smoke potentially. So definitely next year. It's a work in progress, that's for sure.
Excellent notes, and it's very, very interesting, and we look forward to seeing what data and research comes out of this year. Perfect. If anyone else has any other questions, feel free to pop it in.
Can I ask a question? So I know the smoke came over during 2020, right? From all the fires on the West Coast, but I have no idea how fresh that smoke is. Did producers end up being impacted based on wines that were made or analysis?
So I know in 2020, so we had obviously the West Coast smoke come over. We also had very local Colorado wildfires as well. We had, so here in the Grand Valley, kind of Grand Junction, 90% of grapes are grown. There was one very local fire, as well as a few fairies towards the Rockies. In terms of whether there was kind of damage or what people did, I actually, I wasn't working here actually during 2020. I only recently came in 2021, so I actually can't answer that question, but I believe At least some people were sending in samples and curious about that. But we did have that very local fire, so I imagine to some extent there was.
I was interested in, obviously the local fires, way more risk because you'll get fresher smoke that way. I'm just interested in the smoke that came from here because, you know, I don't know how fast it got, how quickly it got to Colorado and whether that actually had an impact. But this is a problem. If you are exposed to smoke from different sources, you end up not knowing what is fresh and what is old, and, you know, you have no idea.
Exactly. Okay, it looks like Chloe said, yeah, we sent in quite a few samples to various people and we did not have any signs of smoke in. Okay.
That's right. That's great. This is the thing, you know, smoke impact can happen really quickly, but really needs to be fresh smoke. We really see that fresh smoke is the main risk. And like I said, even here at our Robert Mandama Institute Vineyards, we got smoke from the complex fire, the lightning complex fire. And it took about a day to get here. It hung around for 2 weeks. We even had ash, visible ash, enough that I could collect a bucket full of it. And most varieties aren't impacted. And now some of your, you know, we don't know quality wine, and, you know, the grapes isn't massively phenolic or anything. What we produce here, it's more for the students to train and stuff like that. And the impact is, when I can see it, is really, really low. If I just looked at the air, it smelled like smoke and the impact is really low. So this is why we really can't make any assumptions.
Yeah, absolutely. Absolutely. That's very interesting. Okay.
Oh.
Okay, so I made some Viognier from grapes from Palestine in 2020. I think I tasted some smoked in. Okay, yeah.
So yes, it is possible. So obviously, if you have fresh smoke exposure, you want to get your grapes off the vine as quickly as possible, because the longer they're exposed, these volatile phenols will keep absorbing while there's a high concentration of them in the atmosphere. However, after you picked berries, they still have enzymatic activity. They're alive for a long period of time. So we do tests on table grapes, right? We buy them in the supermarket off season, you know, when we don't have wine grapes to work with. We expose them to volatile phenols, they absorb them and then form bound. So this is the problem. So while they're in their picking bins, they are sensitive to smoke. Now, is it more than would have been if they were just still hanging on the vine? I don't know, right? But the fact is, yes, that they're not safe because they're picked. They're only safe when they start fermenting. They have a carbon dioxide blanket that protects them against the volatile phenols in the air.
Yes. Excellent. Perfect. Well, I don't see any more questions. I am sure as we get a few more growers watch this once I post it online, I'm sure they'll send me a couple, so then I'll probably send those over to you at some point. But yeah, but I think, yeah, thank you very much for giving us the time. It's great to listen to this very important research that you're doing, which is obviously going to be affecting Colorado more in the future. So this is, yeah, we excellent. Maybe we can do a follow-up as well in a couple of years and get some updates on the research. Yeah.
Yeah, I mean, reach out to me next summer. Like I said, we've done a few studies that we hope we're going to have the answers to by next season. And then any updates I have, I can give to you.
Perfect. No, that's wonderful. And then, yeah, make sure we have Jen contact you about the sensory training. And
okay, absolutely.
She would definitely be interested in that. Yeah. Wonderful. Excellent. Thank you, Nita. And thank you, everybody, for attending. And I hope you will have a good rest of your morning.
Yeah, have a wonderful week.
Thank you.
Bye, everyone.